Unit 5, Lesson 1. So far, we have seen quadratic equations in standard form. So those are equations that look like this. Y equals a times x squared plus b times x plus c. And from the standard form, the key point that we can see is the y-intercept. Okay, and that comes from the c value. And the other form that we have seen is the factored form. And factored form looks like this. Y equals a times x minus r in brackets times x minus s in brackets. And the key points that we can see from the factored form are the x-intercepts. Okay. We have also learned how to convert between the two forms. So to convert from factored form to standard form is through a process called expanding. So if we expanded y equals 2x plus 1 times x minus 3, you'd use the distributive property, and that's how we expand it. So you would say y equals distributing, so 2x squared, and then we have that, so 2x times minus 3 is minus 6x, plus 1x, and times 1 times 3 is 3, so minus 3. And then you collect like terms, so we have y equals 2x squared, and the two middle terms are like terms, so minus 6x and plus 1x is minus 5x, and then minus 3. And there's your standard form. And to convert from standard form to factored form, so here we have a standard form, we want to convert this to factored form. Well, we would use in some of the techniques that we have learned. So one technique would be the product sum. Okay, so we take your a times c value, so a times c, which is 3 times 8, which is 24. Look for two numbers that multiply 24, and then add up to 14. And those two numbers, well, you can list all the factors, but the two numbers that we're looking for here are 2 and 12. Okay, and then when we find the two factors, we rewrite the standard form by taking the middle term, the 14x, and splitting it into two terms. So we'll split it into 12x plus 2x, and then we have the plus 8 at the end. Now that we have four terms in our quadratic, we're going to group them, and we're going to factor the common factor from each pair of terms. So pair up these terms, pair up these terms. The common factor in the first one would be 3x, leaving me with x plus 4. And the common factor in the other two terms is plus 2, leaving me with x plus 4. And then we have a common bracket here. Common factor is a bracket, so x plus 4 is the common factor. So factor that out. Create some brackets and write down the leftovers, so 3x and plus 2. And there's our factored form. Okay, so today we're going to introduce a new third form of the quadratic equation, and this form is called the vertex form. And the vertex form looks like this. So y equals a, which is the same a as in factored form and standard form, x minus h squared plus k. And you're going to take some time, and we're going to use marble slides on Desmos to explore the properties of the vertex form. So maybe I'd pause this video at the moment and look at the class code in our Google Classroom and have a look at the marble slides, and then come back to the video. Okay, so hopefully you had a chance to have a look at the marble slides activity, explore the vertex form a little bit. So let's have a look at some equations in vertex form. So here's one, y equals x minus 5 squared. Okay, it's also considered to be in factored form because you don't have a plus. There's no plus k outside, so it could be looked at as factored form. But let's convert this into standard form. So let's write down, okay, y equals x minus 5 times x minus 5. And if we expand this, we're going to get x times x, which is x squared, x times 5, which is minus 5x, another minus 5x, and then 5 times 5 is 25. So two negatives make a positive, so plus 25. Collecting like terms, we have x squared minus 10x plus 25. Now, if we looked at this equation in Desmos, you may recognize something here. So let's open up Desmos. Let's write in y equals x minus 5 squared. And notice what's its vertex. Its vertex is positive 5 and 0. Okay, and its y-intercept, well, we'd have to zoom out a little bit, but you can see the y-intercept is up here at 25. So let's write that down. So the vertex is 5 and 0. The y-intercept is 0 and 25. So the y-intercept from the equation, pretty obvious, is the last term in the standard form. That vertex, however, there's a 5, and notice how we have a 5 in our equation at that location, where we're supposed to have h. Okay, so let's look at another one. Convert this. This is vertex form. It's not factored form. It's vertex form. Because if it was factored form, everything would be being multiplied. All the brackets would be multiplied. This other term at the end would be multiplied, but it's not. There's a minus sign there. It's a vertex form. It can be written as y equals a times x minus h squared plus k. So I'm going to expand this and make this into standard form. So we're going to write here y equals the x plus 3 squared, that's in brackets. That's like in factored form. You can write that as x plus 3 times x plus 3. Then you have a minus 4 outside. Okay. Then what we need to do next is expand the two brackets. So while you do that, you leave the minus 4 on its own outside. So y equals, so let's write here, x times x is x squared, 3x plus another 3x plus 3 times 3 is 9, and don't forget you still have the minus 4. And now we're just collecting two sets of like terms here. So x squared, here's a pair, so 3x plus 3x is 6x, and 9 minus 4 is positive 5. So x squared plus 6x plus 5. So the y-intercept should be 0 and 5 if we know that the standard form, that c value is 5. Now, what about the vertex? So let's have a look at Desmos again. So let's type in the equation x plus 3 squared minus 4. It's that, so x plus 3 squared minus 4. And if we look, zoom in on the graph here, we can see our vertex is right here at negative 3 and negative 4. And y-intercept is at positive 5. So the vertex is negative 3 and negative 4. So again, I'm going to highlight this. Negative 3, we have a plus 3 in the location there. And then negative 4, we have a minus 4 at that location there. Do you see something? H and K are related to that vertex point. Okay, let's try another one. So let's convert this one into standard form, and we're going to check using Desmos. So if I convert this into standard form, the way we do this is by saying y equals negative 2. Turn the bracket x minus 4 squared into x minus 4 times x minus 4. And don't forget you have a plus 1 outside. Okay, so we're going to expand by distributing the terms in the brackets like before. So we're going to say y equals negative 2. Let's create some brackets here because you don't want to mess up that negative 2. So x times x is x squared. Then we have a minus 4x and another minus 4x. And then 4 times 4 is 16, so plus 16. And then close the bracket, and then we have a plus 1. Remember, the plus 1 is still outside of everything. That negative 2 is not going to be distributed with the plus 1 because they're separated by that plus sign. Okay. Then we collect like terms, so y equals negative 2, x squared minus 8x plus 16. Close the bracket. Don't forget the plus 1. And then y equals, let's distribute. So negative 2 times x squared is negative 2x squared. Negative 2 times 8x is plus 16x. And then negative 2 times 16 is minus 32. And then plus 1. And then when we simplify, we get minus 2x squared plus 16x minus 31. All right. And then y-intercept 0 and negative 31 from our c value here at the equation. Okay. What about the vertex? So the vertex, even without going and looking at h and k, you might remember how to find the x-coordinate of the vertex just from standard form. And the x-coordinate of the vertex is just negative b over 2a. So if I calculate negative b over 2a, you would get, okay, so negative b is 16. This is my b value here. So negative 16 divided by 2 times a is negative 2. So 16 divided by 4, which is 4. Two negatives make a positive, so x is positive 4. And then so the y value of my vertex, if I put this back into the equation, it would be negative, I'll use the equation they gave us in the question here. So negative 2 times 4 minus 4 squared plus 1. Well, we know 4 minus 4 is 0, so that goes away. 0 times negative 2 is still 0, so that goes away. So y equals 1. So I would expect my vertex to be 4, comma 1. X is 4, y is 1, so it's 4, comma 1. So 4, comma 1. Now let's verify this using Desmos. So if I go to Desmos, so here we have a new equation. So y equals negative 2, x minus 4 squared plus 1. And if we look at the vertex, here we have 4, positive 4 and positive 1. Exactly what we said here in the vertex. So again, let's just double check the y-intercept too. So the y-intercept over here it is negative 31. Exactly what we had here. So again, vertex 4 and 1, is that related to my vertex form equation? It's called vertex form for a reason. You should be able to see the vertex. So here we have the x-coordinate is 4. Here in the equation it's minus 4. So think about what, notice so far that the x-coordinate, the vertex, kind of has a minus 4 in there when the x-coordinate is positive. However, the sign makes more sense with the y value. So if y is positive 1 and the k value is positive 1. All right. So what do we learn from that? Well, in a vertex form, your vertex ends up being h and k. Okay. As long as the form of the equation is y equals a times x minus h squared plus k. All right. What if we were going backwards? How are we going to convert this to vertex form? So if you had standard form, well, standard form has a y-intercept of 0 and 3. So if I wanted to convert this to vertex form, I would need the vertex first of all. So let's find that x-coordinate of the vertex. So negative b over 2a. Well, okay, so b is negative 14. A is the invisible 1. Okay, so negative of negative 14 over 2 times negative 1. Sorry, 2 times 1, rather. Positive 1. And so that's going to be 14 over 2, which is equal to 7. The y-coordinate of my vertex would be, well, let's plug in 7. So 7 squared minus 14 times 7 plus 3. And that would be, okay, 7 times 7 is 49. 14 times 7, a little bit of more math to think about, but that's going to be 98. And then plus 3, and that's going to equal, let's see here, negative 46. So my vertex would be 7 and negative 46. Now remember what he said about the vertex. The vertex is h comma k, and so that would be 7 and negative 46. So my vertex form equation would be y equals a times x minus h squared plus k. And I said a is going to be the same value of a as in the standard form, so y equals just 1, so I'm not going to write that. X minus h, you said h was 7, so I'm going to have to write here. Like minus is part of the equation, so x minus 7, and that's squared, and then plus k. So k is negative 46, so I'm going to say minus 46. And that would be my vertex form equation. Now let's plot that just to verify that this is true. So I'm going to go back to Desmos. So write y equals x minus 7 squared minus 46. Zoom out a little bit so we can see that graph better. And now I'm going to plot the standard form given to us in the problem, y equals x squared minus 14x plus 3. And you can see the two graphs line up. These are equivalent quadratic equations. Okay, so Let's try another one. So let's convert x squared minus 12x to vertex form. So this is just like standard form. So we're going to say here y equals x squared minus 12x plus 0. C is 0, so my y-intercept is going to be 0, 0. My b value is negative 12. So if I were to find the vertex, well, I'm looking for the x coordinate. So negative b over 2a, which would be negative of negative 12 over 2 times 1. Remember, there's the invisible 1 there. And that's going to be positive 12 over 2, which is just 6. And if I were to find the y-coordinate, take the x equals 6 and put it into the equation. So 6 squared minus 12 times 6, which is equal to 36 minus, well, 12 times 6 is 72, and 36 minus 72 is negative 36. Okay, so my vertex, h and k, is, well, the x-coordinate is 6, the y-coordinate is negative 36. Now when I write the vertex form equation, a times x minus h squared plus k, we're going to say, well, a is 1, the invisible 1, so y equals, I don't need to write the 1, I need to write the bracket, so x minus h, so h is the x-coordinate 6, so x minus 6. So again, it's not x plus 6, you have to include the minus sign, okay? If the vertex was a negative number, then you do x minus negative, which becomes plus. But here, it's just x minus whatever the h value is which is 6. Then that's squared, plus k. K is negative 36. So I could say plus negative 36, or I could just simplify it, skipping a step by saying minus 36. And there's my vertex form, and my vertex is 6 and negative 36. And I'm also going to plot this on Desmos to show it to you as well. So let's see here, x minus 6 squared plus minus 36. So let's do that. Y equals x minus 6 squared minus 36. So there's my equation in vertex form. And now I'm going to plot the equation in standard form given to us in the problem, so x squared minus 12x. And you'd see that the two graphs line up. They are equivalent equations. Okay, all right, let's do one more. Let's convert 2x squared plus 12x plus 11 to vertex form. This is my standard form. So a is 2, b is 12, and c is 11. So let's find the vertex. Well, actually, we can write the y-intercept. So the y-intercept would be 0 and 11. The vertex would be x equals negative b over 2a. So negative b is 12 divided by 2 times a, which is 2. So 12 divided by 4, 2 times 2 is 4. So 12 divided by 4 is 3, and that's negative. So negative 3 is my x-coordinate. My y-coordinate would be, let's plug in the negative 3 into the equation. So 2 times negative 3 squared plus 12 times negative 3 plus 11. And solving for y, we get 2 times negative 3 squared is positive 9. 12 times negative 3 is negative 36, so I'll say minus 36 plus 11. And so 2 times 9 is 18. If we subtract 36 and add 11, we would get a y value of negative 7. So now our vertex h and k is x-coordinate is negative 3, and the y-coordinate is negative 7. Let's write that here, negative 3 and negative 7. Now if I was writing vertex form, I would say y equals a times x minus h squared plus k. And so a we know is 2 from the standard form, so y equals 2 times the bracket x minus h. So here's what's going to happen. So I'm going to put x minus, it's part of the formula. H is negative 3, so I'll write negative 3. And that's close bracket squared, and then plus k, so plus negative 7, right? So we're going to simplify the signs. So y equals 2 times x minus negative 3 becomes x plus 3, and that's squared, and then plus negative 7, we can just say minus 7. And there's my vertex form. So you got to be careful with that sign there with the h. And we're going to plot this graph just to show you that this is also equivalent to the standard form. So let's go back to Desmos. And we're going to write here, let's erase these graphs. So y equals 2 times x minus x plus 3 squared minus 7. And the standard form given to us in the problem is y equals 2x squared plus 12x plus 11. And you can see the graphs line up. The standard form and vertex form are equivalent equations. And so that's how you do it. That's how you convert from standard to vertex and from vertex to standard. There are other techniques to find the vertex form, which we'll study later on in this unit as well. Okay, and that ends this video.